Hi everyone, welcome back. Lastly, we learned about how to initialize BRISK method of this feature detection and description. Also, we compared BRISK with the other methods we already learned related to this 2D features framework module. And in this video, we are gonna focus to the member functions of this BRISK class, and there are not many like the others, only octaves, pattern scale, and the threshold. So we are gonna focus these three member functions. And this was the code from the previous video. If we run this, we simply just see here the key points, detected key points with the yellow circles. For example, yeah, there are some points in here we already discussed also in the previous videos. There are some corners which we don't see from the big picture, but in reality it calculates via on the BRISK backend. There are some corners, key points in here, so it's detecting and it's showing us. We can eliminate this by the threshold only. We will see that part, and yeah, this was the example from the previous video, and now we can switch. For example, in the right side we can open this BRISK class and we can check each member functions here. So maybe we can start with the octaves, and we continue on that one. Basically, maybe we can see the default octaves value, so we continue via on that. Okay, just get octaves, and here, okay, and L. Okay, so let's see the default one first of all. So default is 3. So what is this octave means is that for example, this currently 3. If you give the lower values, you are gonna get less key point, less corners. If you give higher values, mostly you are gonna get more key points. But according to what? For example, this is 3 and it sees some corners and it gives you as result. For example, this black circle, half circle maybe we can say, how far you are looking at to this circle. For example, imagine this is a small piece, very small, like here imagine there's a very small pixel area. Let's say if I zoom here, let's imagine there is a same circle which we see in the big screen. Let's see there is a circle here. So this huge this new circle, which is a smaller area, with this current image from this scale, is gonna be recognized as key points maybe. So this is kind of how far you are looking at to the picture. So if we give high values to octave, for example, here just set octaves. Okay, let's give 9, which is 3 times bigger than 3, and let's run it. Now you are gonna see something weird points. For example, you can say there is no corner, there is no key points here, but how far you are looking at it. So imagine this is you are looking from really far, so you can maybe give it logic. So this can be a key feature in my big picture. So how far you are looking at. So if you make it smaller, which is very closely you are looking, and now yeah, also some eliminated, so some is not recognized, but it's also giving, since it's checking little focusing area, so it's more easily can see these are the key points, these are the corners. So basically this octaves doing this job. And the next we can get pattern scale. Actually this is related to the maybe we can see the default value. This is related to the descriptor. I'm planning in the future making a video about using this descriptor, because this is not about, now we only see the key points, which are the corners, but descriptors are for each key point we have a descriptor. So for example, there is a circle, there's a point here, so according to this point already has a array which is including the descriptor numbers. So those descriptor numbers are calculated via on this also parameter get pattern scale. So if you're giving lower values, which is about you are gonna get better results to compare. For example, there is an image here, and imagine there is one more but high resolution image which is including the similar key points, similar shape, and in that one, if higher resolution than this one, more high resolution, so you need to update this pattern scale according to high resolution. So this is just about a parameter which is related to this descriptor output, so it's not directly affecting the key points. So since we are not gonna focus, because this descriptor topic are you need to compare the arrays always for each key point. Then you can say these are the similar key points, these are the similar corners. So I'm planning to make a comprehensive video related to this descriptor, so I'm gonna skip this pattern scale kernels, but you can keep in mind this is high resolution and low resolution but similar key points. This parameter is just affecting resolution based key point comparison. Okay, now threshold is the easiest one. Also, for example, let's see the default ones. This is integer, in some cases this is double, so for different type of feature detection classes it has different types. Currently is 30 and we see some ugly detection here, so for us ugly, but in backend the logic is saying this is a key points which is correct because there's a mathematical method is calculating this as a corner. And now we can eliminate that by just increasing our threshold. For example, currently 30, and set threshold, let's make 100 and let's see how it looks like. Okay, now pretty clean here, gone. You see mostly the corners are giving well. We can increase more also, maybe let's say 150, how it's gonna looks like. Oh, I didn't notice big change, maybe we can make 200. Okay, still don't see big change. Let's make 250. Yeah, now I see change. Now some is gone also, but at least the points is giving more clear, more better, I can say, comparing to other one. Yeah, this threshold is doing that. Also, if you give less results, let's say 10, which is smaller than 30 default one, and you see more corners. If you increase more, if you decrease more, you are gonna get crazily high amount of corners. Yeah, so for this video simply we just talk about this 3 member function which is belonging to BRISK method, and we are done about this BRISK method, and we are gonna continue with the new methods in this list in the next video. I'm done for this video. Thanks for watching. See you in the next videos.